Good morning. Thank you for the introduction. As mentioned, my name is Etienne Posthumus. I'm based in Amsterdam in the Netherlands, but I'm speaking with you on behalf of the ISE group from FIZ Karlsruhe in the ISE group from Professor Harald Sack, as mentioned. And my presentation today is about knowledge graph-based research data management solutions, and starting from NFDI for culture, but also a very brief glimpse at the next steps where we move beyond that. At the FIZ Karlsruhe, we have very many projects and services that has some links to knowledge graphs and also to several NFDI consortia. So here is just a very bird's eye view of many of the projects that we're involved with. And it ranges quite across the board from the cultural heritage domain and also into the more hard sciences domains, for example, in the material, digital, and Maatwerk consortia. It started way back in 2020 at the FIZ Karlsruhe with the NFDI for Chem, and then we've also moved towards other consortia, NFDI Maatwerk, the MARDI for mathematics, data science, NFDI for memory, and then what I'm involved with, the NFDI for culture, which I'll be sharing today. What we're trying to do with the NFDI ontologies is to see if we can develop a modular approach. So we're starting with the very basic, at the base level, the NFDI core ontology. And that's very much information about the consortia in general. And then on top of this core basis, we'll be building extensions and modules for specific consortia, because there would be specific things for a certain consortium which doesn't make sense. So if you're dealing with material science and you have measurements and processes and workflows, they would completely not be applicable if you're working with cultural heritage, for example, and vice versa. So this modular approach is needed, otherwise your ontology becomes way too complex and top heavy. So coming back to this idea, you want to try and be able to do simple things and then build on top of each other and copy things from each other where possible. Mentioned in the introduction, making simple solutions to complicated things is actually incredibly difficult. I'm sure you've done that yourself, where if you see something that's very simple as an end result, often there's an incredible slog of really complicated things that came before that have to be scrapped. And then it looks very easy, and you go, oh, but is this it? Is it this simple? And that hides the fact that sometimes it's way more, it's the same as if you write a paper. To write an incredibly clear, simple paper in easy language is way more difficult than filling it with complicated jargon and, really, you just spew out what's there in a complicated fashion. So we're trying to reach this idea of simplicity. We're not quite there yet, however, I have to say. So you're seeing a sort of in-between of the final idea of the simplicity and the messy parts that we're still busy with at the moment. The NFDI core ontology was born out of the NFDI for culture ontology, because that was the first one that we started working on. And the idea is to do this as a bottom-up approach, to always have what you're doing based on actual research that you've done with your users and actual research questions saying, what is the actual problem we're trying to solve? And not just having some kind of architecture, astronautics, designing things which you might need in the future or you possibly want to describe at a certain stage. And that once again makes things far too complex. So we try and only add things based on actual data points that we have, that we can say, yes, we are recording this because someone wanted to say something about their research data. And in the core, it's information about the consortia. What kind of services are there? Who are the research groups? What kind of data sets do they have? What kind of guidelines? What kind of documents? It's a very much a meta level. is in the core. And at the moment, there's 33 classes in it and about 60 properties. It also is linked to external vocabularies, because the whole idea of linked data is that you link it with other things. So the more you link your knowledge graph to other knowledge graphs, the value of it increases exponentially. So if you only do a knowledge graph and you never actually link it to other external sources, it becomes very, very limited in its usefulness. So in the NFDI core, we link to over 20 other external vocabularies, schema.org, Fabio, Frapo, Void, DC terms, FOF, etc. And we're trying to document this in the open on GitHub so that you can follow along. And if you have comments or questions or discussions, please do add them on GitHub. It's separated into two parts: the research information graph and the research data graph. So firstly, the research information graph. What is that about? It's the index and the metadata for project resources, data resources, data services, actual persons. So you can go and look for a person and see what projects are they involved with, or vice versa, institutions, expertises. And it's used as a back end or as a layer for the NFDI for Culture portal, which I will also be speaking about a bit later on in the presentation. Linked to this meta level, we have the research data graph. And this would be the rest. And we're busy filling this at the moment. The information graph is already filled in because we know which persons are in our consortia. We know which institutions are taking part. But the data graph, we are not yet there. It needs to be filled in. And this is the actual research data contributed by the members of the consortium. So this would be, I will get to some examples in a little bit later, but if you have some kind of research output in your group, for example, one of the first ones is stained glass windows. So we have a project that documents stained glass windows, and this gets put into the research data graph. The purpose of this is so that you can go and find other research data in a linked way and find what other people have presented as the output of their research. And it can be used for analysis or for linking or for discovery or exploration purposes. So these two things combined, the research information graph, which is actually quite small, and the research data graph, which will be growing and will become bigger and bigger. This is now what we call the culture graph 2.0. So this is the next step in our culture graph or our knowledge graph for research for culture. A key point of how do you get the data into this research data graph is deciding or recommending to your partners how they can contribute their data. Especially in the cultural domain, a problem is that institutions often cannot change their web servers easily. They already make use of a service provider that provides with a content management system, or they use a certain website building service. And we can't ask them, yes, just add this and this URI to your service, implementing such and such an API, or build a Sparkle endpoint so that we can harvest your Sparkle data. It's too high a bar. So we were thinking, how can we solve this problem that people can still contribute data in a structured linked data way, but not ask that they implement a Sparkle endpoint or implement such and such a specified web API. And the solution that we've devised is the culture graph interchange format. Now it sounds all spiffy, but it's very similar, and it's inspired by the schema.org JSON LD snippets that you can put into your pages. And it's very much based on real world data that people use in the Google data sets specification. And it's actually very simple. You add some a script tag on your web page with some JSON data inside your web page. And this can often be done by people doing their web templates if they're doing it in WordPress or Typo3 or Whiskey or whatever your system is that you're using to create your web pages. You can often add these kind of JavaScript snippets inside the page. And it contains the actual structured data as linked data to exchange with the partners. And we've created, as you can see on this page, there is some documentation on it, the very first version. And we're busy improving this as we speak with the first partners that contributed their data. And it has some added benefits. Here is the example of the first contributor from the Academy of Sciences in Mainz. They have a project called the Corpus Vitriarum, which is a stained glass research project. And they have now added some of these JSON LD snippets to their webpage, where we can go and harvest the metadata from their pages and add it to the research data graph. Once you do this, it also has other kinds of benefits. Because we are using the system which I mentioned earlier, Icon Class, for example, at the CVMA, you can link their research data output to other sources. So going via the research data graph, we can go and say, I would like to go and see other resources for a very specific abstract concept. In this example, it's the concept of the wild man, the Wildeman. And you go and search in Wikidata or in a museum in the Netherlands, like the Rijksmuseum, for show me other things, which has this very specific kind of abstract concept. It doesn't have to be cultural specific. Of course, it could also be, in a German context, GND keywords that you're using to link your data, so that you could then go and search in the Deutsche Digitale Bibliothek for other contents. But by using these kind of linchpins, you can create a web of data and enrich your research data with other sources. And almost as an added benefit and for free, if you're doing this in this manner, you also have improved Google SEO dataset improvements. Because we've based it on the schema.org system, your website that implements this becomes visible and searchable in other search indices like Google, almost for free as such, for the effort that you've placed into it. On these links mentioned, there are some use cases and there are some reports from the team in Mainz on how they did this. There are other variants. So what I've skipped over here is linking data sets that are already in Sparkle or are already as a knowledge graph, because that's almost the easy one. So we can just link to them as a federated service. So the CGIF is a special case for partners who do not have Sparkle endpoints or existing APIs that we can harvest. We're also looking into other use cases. For example, a very popular system that's used by many partners is Wikibase, which I'm not sure if I don't know. I can't see so many people raising hands. Are there people within the Dahlia project that use Wikibase? Is it a familiar or a well-known thing? Nods, yes, no. Yeah, I can only see two faces. So if Constance and Jan Michael doesn't nod, then I'm saying I'm taking it as a no. But it is very popular in the NFT agriculture community. And we are looking at linking up also with Wikibase as a source for research data. Briefly speaking about the culture portal, I mentioned that we use the the knowledge graph as a substrate as such for what gets published in the culture portal. As such, everything that we have in the culture portal gets a unique IRI so that you can reference it with a proper link instead of just having strings in your data. Now, I'm not sure whether this credo of things, not strings, is familiar to everyone in the group, because I'm, to be honest, I'm not really very sure what the background is of my audience that I'm speaking to. So if it's a technical, can you briefly mention, Constance, is it the people in the audience, are they technical? Are they managerial? Are they, what, briefly?
So I think most of the people have a technical background today here.
Okay, right. So then the idea of things, not strings, is familiar to you. We want to have links where possible and not just reference people by name or institutions by name. And so, yeah, we're trying to eat our own dog food as such, to use that expression. So every person, for example, here you can see Harold would then have he's within the NFDI for culture context and ID. And the same for our task areas or the outputs to have the knowledge graph. Everything has its own IRI, and then we can refer to it within the bigger knowledge graph, and you can use it to query and ask questions in this manner. Now, what's the technical part? How does this work, you might ask? In the NFDI for culture context, we've based it on the Typo 3 system, which is very, very popular in Germany. And the team in Mainz are also really, really experienced, and they know Typo 3 very well. So it was quite a natural step to build upon this system. And there's the CRIS extension that was developed by the team in Mainz for Typo 3. And this forms the heart of the data model for how we express the research information system. What kind of entities are there? How are they related? How do you express what things are, and how to link one thing to another thing, and the concepts as such. And this forms the heart of the knowledge graph, the research information graph. In addition to the CRIS extension for Typo 3, there's also a linked open data extension for Typo 3 that allows every page, as you would normally know it from a CMS point of view in your Typo 3, to also be expressed with linked data IRIs, and that you can then query it and export it using a web standard. And in this case, the web standard that's used for querying and exporting is the Hydra API, which is also fairly well known within the linked data community for how to express information about web resources, what the feeds are, how can you enumerate them, how can you download them when you need them, and it standardizes many of these kind of questions that you might have. The RDF extension exposes all this CRIS information as cool IRIs, or cool URIs as they used to be known, so that you can dereference them and download them in different formats. So either as a turtle file, or JSON LD, or an NTripl file, these kind of things, or as a just entire collection. What we then do is we harvest this RDF data and we put it into a Tripl store, and we expose it as a Sparkle endpoint, which is one of the URLs in the culture portal. So in a sense, it's almost like a snake eating its own tail. The data that's inside the CMS, inside Typo 3, it's exported and then exposed as Sparkle as one of the URIs in the CMS. And you can then sort of in this way query the system itself using a structured query language, Sparkle. Different kinds of users would want to access the data. So on my screen here, the green user icon would be an arbitrary user. They have no authentication. They are just a viewer coming along to find some information. You might also have an NFDI for Culture authorized user who can do more things. So they can actually enter data into the CMS and do various things with it. And they would have a different view of the data than an arbitrary visitor who's just visiting. On the Sparkle endpoint, you have the same kind of distinction. There could be an arbitrary user who is just querying the Sparkle, but because it's structured data, we can actually create automated services that can link these systems together, either to harvest the data in bulk, incorporated somewhere else, or you could have some kind of an interactive system that queries the data and does interesting things with it. Now, of course, in the last 6 months, our world has exploded with the use of large language models and chat interfaces. I'm sure in your group as well, it's a very hot topic and everyone is sort of rushing, trying to figure out what can we do with these things. And in our group, it's also one of the questions we're trying to investigate is how can we use knowledge graphs to prove veracity of facts that are being spewed out by a language model. So this is one of the problems. You are told things, it's amazing, you're quite excited, but then you need to verify is this actually true? You've heard the stories of librarians going nuts because users are coming to them with fabricated citations to publications that don't exist. Now you have the same problem with facts. How can you actually automate these kind of interactions to double check things? And how can you do reasoning and logic about fact checking? And we think within our group that there's a lot of scope for this to try and combine the usage of large language models and automated reasoning to try and see how you can use the strengths of both in this kind of way. Yeah, and in the same way that you have an NFDI for Culture authorized user, you would also have an NFDI for Culture expert user that might be doing more advanced Sparkle queries, visualizations. And once again, because it's structured data, it enables them to be able to do these kind of advanced queries. Here is one of the visualizations done by one of our partners to try and figure out, so what's inside the knowledge graph. And they created this really interesting looking graph, sorting it out by types. But that's just one of the examples that you could do because you have the full power and the expressivity of Sparkle. You can do whatever kind of query you might want to do. I'm quite curious in this group, within the Dahlia group, how many people use Sparkle, are familiar with it and are happy with it, or have opinions about it? Can we have a short feedback from someone? Please, go ahead. Let's see. Abdelmanen?
Yes. I worked with Sparkle in the past. Yeah, I'm not sure. And we are going to work also with to make a knowledge graph that, and there will be interface which will be in a Sparkle, or uses Sparkle also to a table store that contains the learning material and so on. So this is briefly what we see about.
Super, thanks. Frank.
Yeah, I'm the person who has to provide and kind of implement the triple store. So I also cope with Sparkle and the protocols behind that, the libraries, of course.
Yep. Thanks. So I'm asking the question out of interest because I'm one of those persons that until very recently was a very vociferous Sparkle hater. And you encounter them very much within the web development community and software developers in general, you show them Sparkle queries and they just like, it's like, you know, go away, we're never going to use this. And as a linked data community, we often very much push it as just I should grab a glass of water.
Go ahead. Oh, we have time.
Excuse me.
Yeah.
I'm just going to grab a glass of water because otherwise this is going to go not good. Hold on a second, please.
Please do so. Yeah. So I hope we will get the presentation also afterwards, because I see many links here, and I think they are interesting for us too, right? I tried to call some pages, but there were just too many, so I will ask him for the slides in the end. Maybe it's a good time for everyone to pick a glass of water.
Right.
I don't know how your temperatures are, but here in Darmstadt, it's 32 degrees, I think, and it's very humidity, high humidity air here.
Right. Sorry about that. Where was I? Yes, Sparkle. So it's for me always very interesting to try and gauge what is the temperature in the room with regards to Sparkle. Are people still opposed to it, or have they come around and have they invested the effort in trying to use it? And do they in general feel there is a future in using it? Or do they decide, well, we will create APIs ourselves that is more closer to what our users want, and we want to shield them from Sparkle? So it's always a very interesting question for me, what the approaches are from potential partners. It's interesting for me. Is there anyone with experience within this group of a system like IIIF or images in cultural heritage, or distributed text services for text encodings, potentially? Yeah, no, right. So what I find interesting about those is there are systems that are in its heart very much linked data. It's all expressed using RDF ideas, but they're not exposed via Sparkle. They all have their own HTTP APIs, which sort of freeze the views of the RDF data. And it's a different way of dealing with your RDF data. So it still uses the core RDF, but you just don't have Sparkle, which I always find a fascinating approach. Right, moving on to some next steps. Where are we now? So we would like to enable interactive knowledge graph extensions and the registration or the curation of data sets via the culture portal. So in other words, at the moment, we've filled the culture portal with data, but we would like end users to be able to add their data sets, register new partners within the project, and it become an interactive system for managing the data. The NFDI core, of course, is not finished. So as we're working on it, we identify we need to add extra properties, or we might want to record ISIL codes for libraries, or these kinds of new extensions. Or we might discover that there's a property that's being used or suggested by one consortium that becomes valid for many other consortia. So we want to move that into the core. Or we might discover that certain parts in the core is only really used by one consortium, so it should be removed out of the core and really just go into one of the other modules. And we also want to look at, should we integrate this with other systems like the Whiskey system, which is also fairly popular within the German research community. We want to try and stimulate adoption and implementation of the CGIF format by other NFDI for culture partners. And we're filling this research data graph. So the challenge is to try and ensure that the quality of the data in the research data graph is as good as possible. And that old story about things, not strings, is harder than you think. It can be incredibly difficult to ensure that people use links, use proper EDs everywhere. It's quite a challenge. It's quite an uphill battle. And eventually, we want to make sure that our research data graph can also be federated with other knowledge graphs so that we can link it to Wikidata, the DDB, Europeana, and also other NFDI knowledge graphs. So that's the end of my blah, blah, blah. Thank you very much for your attention. And I'd like to open up for any questions or discussions that you might have.
First of all, thank you very much for the presentation. I'm going to stop the recording now.